Hello everyone, hope you guys are enjoying these tutorials. In this video I will give you an overview of the piece of software named COPASI, or Complex Pathway Simulator, that we have here on the screen. If we click on the icon, COPASI will open. And first of all, I would like to explain to you what is COPASI and why do we use COPASI. COPASI is a software application for simulation and analysis, and we use COPASI to model networks, and not only to model the networks but also model the dynamics of the network. COPASI is a very user-friendly piece of software that has been developed within the Modeling Immunity to Enteric Pathogens Center, and we mainly use COPASI for ordinary differential equation modeling. Now, I would like to walk you through the different menus of COPASI. We have an upper menu here with some basic tasks such as create a new model, open an existing model. We can save the current model we're working on. We can also capture the main window. We also have the sliders here, and I'll be talking about those sliders later. We can check the model for debugging. We have some other options here. Also, we can update medium. We're not gonna get into that. We can select concentrations or particle numbers depending on what we want to model here, also on the upper part menu. Just the regular menu here on top. We have the different options. A lot of things are repeated here, but just I'm telling you guys so you have a reference that you guys have this menu here. Here in the middle we have two parts. The left element is called the object tree. The other element will change, and it can be modulated by a slider here in the middle. This comes in handy when you have big names for species. But anyway, the left element shows your current model and the tasks you can perform. You can open the different menus, and there are a lot of options. Here you can see everything you can do with your model, your compartments that you can build, also the species that you can put in your model. This will be your proteins, your nodes, the reactions, which link the different proteins or nodes. And then you'll see that there are other options, but depending on what you click, the part of the right will change. The model is divided by model and then tasks. We'll get into the tasks later. I want to touch on the functions. There's another tab named functions, and these are all the dynamics that you can use to model the different nodes you have. Let's get started explaining the different parts of the modeling section. First, you have your compartments. The compartments, as I explained in the Cell Designer video, are the delimitation of your model. Let's take a look back at Cell Designer, and I'll show you an exact example of what I mean with that. If we just create a new file, I just want to show you how, by clicking on the compartment, the square, oval buttons, you can create what we name the compartments. Now you can have a model, for example A, we can call protein A. Also we can create another protein, for example named B. So you can have one compartment that has two different species, A and B. In contrast, you could have two compartments. Let's say C2 in this one, and let's create an exact same one named C3. Now let's create again two species. We can have species A1, and we can have species, for example, A2. Now in this case there are two different options here. We have an option on the left and it's just one compartment, versus an option on the right where there are two compartments. A1 is in one compartment and A2 is another compartment. How do we represent this in COPASI? Well, we can create different compartments, and this is the place you do it. So here on top, let's say this is compartment number 1, and then we have different options from here. For instance, fixed means that the volume of the compartment has a constant value, and that corresponds to the initial value we gave. Assignment, the volume is determined by evaluating a given mathematical expression that we can put in here. Last, ODE, the ODE, the rate of change of the compartment's volume, is determined by an ODE that at the same time we can type in here. Let's just put fixed. I usually use fixed compartments, and I usually put a value of 1 for one compartment. And let's just make this difference between the compartment on the left and the compartment on the right in Cell Designer. Let's create a second one. By clicking a new one, you can put compartment 2. We can also leave it as fixed with a value of 1. If we press commit here, everything will be saved, and we can go ahead and check that we have two compartments, compartment 1 and compartment 2. Let's move to species. What are species? Species are our nodes. So here you can see how we have different options. If we double click on that, we can add the name of the species. This one we can call it A. And again, we have different options here. If we have reactions, the amount of the species or its concentration is determined by the kinetic laws of the reaction that modify the species. And I'll get into that a little bit later. Fixed, the concentration of the species has a constant value and it's always the same value, so this value won't change. Assignments, the concentration is determined by evaluating a given mathematical expression that we can specify here. And last, ODE, again, the rate of change of the species concentration is determined by an ODE that we can also assign here. For species A, let's just go ahead and click on fixed, and the initial concentration of species A will be 100. Now, you'll see how when we start adding reactions on species A, the reactions that involve species A will appear in here, but this is not happening yet. One thing that I want to show you is these columns here at the end, the concentration, the rate, the initial expression, and the expression. These cannot be added by the user. All these values will be set by the software and calculated automatically when you do, for example, a time course simulation and the rates are calculated. Also see here, if you click, how you can change compartment 1 and compartment 2. COPASI will always use the first compartment as default, but you can change that in the menu or also here if you double click in the species. Next, the reaction. By double clicking, it's very similar to what we do with the species. We can add a name, for example, a link, and we can put I is going to get transformed into B. See how I use this notation here. I can use an equal sign and that would make the reaction reversible. See how here I only have A, but I have B written here. COPASI is a smart piece of software. If I go ahead and press commit, do you see that in the species now I have a B? COPASI has detected that I'm creating a reaction that involves a species that I did not put, and now it's creating it. Here you can see the rate law. If we click in here, we have different options. These are different functions on how our reaction is going to behave. You can also create a new rate law, and we'll get into that in a bit. And also you can edit a rate law if you've created it. Last, you have your parameter that will modulate your reaction, and we can change the value here. If you check the mapping, it's local and it says unknown, and we'll get into this a little bit later. Now what we are going to do is to add another reaction here. You can click actually here and type the name of the reaction and also what the reaction is going to be. So for instance, in this case, we're going to have a state transition from B to C. You can see here how C has been created now because there's a reaction that has C written in here. We're going to leave everything the same, but now, for example, we want C to be in compartment number 2. We can just click in here, and also now you can see how C is involved in these reactions, whereas B and A are involved in different reactions. Let's take a look at the reactions. I was talking about these values, 0.01 or 0.1 in this case on the billing. Let's go ahead and change it to 0.01. In this case, do you see how both of them are the same? Here's where global quantities come in play. Global quantities are just numbers that we set, and we can use these numbers throughout our model. For example, in this case, we can create a global quantity by double clicking, and we can say, okay, this will be parameter K1 for A and for B, and the value will be 0.01. If we click commit, and now we go to the reaction, of course, we've seen how this has been created. The mapping now gives us another option, which is the global quantity. So this comes in handy when you are dealing with very big models, and now you have the 0.01 here that you cannot click, and you can do the same thing here. So if we are to create another reaction and we want to use 0.01 as our value, we just need to reference K1A to B. Of course, we can change this parameter anytime. If we want to have 0.02, we can change it in the global quantities, and then if we click back to the reactions, you'll see how the value has changed in here. Let's take a look at the events now. The events give us a lot of flexibility on what can happen. Probably we'll get into that when we are with the CD4 training. Finally, the parameter overview gives us, as the name says, an overview of everything that we have in the model. It comes in handy, especially when you're writing papers and you want to create tables. That comes in very handy. One nice feature of COPASI is that you don't need to write the ordinary differential equations yourself. Remember, guys, we are immunologists. We don't know much about mathematical equations at this point. So if we just press differential equations, COPASI will give us these equations for us. And again, this comes in very handy when you need to put these equations in a paper. There are different options that we can use once we have different functions or different parameters or different values. We can display the name, we can display the value, etc. But this is up to the user and what you want to show. Now in this reaction, do you see how there's this mass action irreversible? We can actually change this and choose another type of dynamics. And all the functions that we use are here in the last submenu. See functions here? If we scroll all the way down, there's an option here that allows us to create a new function. But we can pretty much use everything that COPASI has if this is the kind of dynamics that we want our reactions. As I said, new function at the end, we double click, and very similar to other parts of COPASI, we can add the name of the function. Let's say this is example, and then here the formulas. There is a ton of annotation and documentation in the COPASI website about what you can put here in formulas. But for example, if we want to have a parameter multiplying an activator and that multiplying a substrate, for example, we can annotate it like this. And then you can see here at the bottom of the page, when we press commit, this of course will give us an OK. But you can see here how we have different options. Activator would fall under a modifier. It modifies the reaction. Substrate would be a substrate. And K would be just a parameter. Now if we press commit, let's change that to, for instance, a KSA. K substrate activator. Do you see the new function that has been created here? Now if we go back to the reactions, let's say we press, let's go with B. In the rate law, now we have the KSA option. If we press KSA now, you see how now we have an activator here. Of course, we can still add the K1AB, but if we add that, this will go back to mass action. So we can go back to KSA and just give a different value. We can also select which is our activator. In this case, B will go to C, and it will depend on the concentration of A. And then we can modulate this with the parameter that we want. Here we can edit that. In case there's something that is not working, we can just go ahead and edit. We can also create a new one for B. And again, we can give a name, we can give a formula, and we can specify what is what. In B, let's go with the mass action as we had it before. And we'll go with K1AB. Perfect. If we press commit now, I can show you how the model is now structured. We have this model, we've given the overview. We can also give a name to the model. As I said before, we can call this model, well, let's put the example model. Any notes, we can make a note here, something like, we are about to finish this video tutorial, or this video. Okay, here you select your time unit, and this is just in case you're dealing with cellular levels or intracellular. You want to make sure you're on the right time scale. Same for the quantity units. Let's go ahead and do molar. And for the volume as well, we can select liters, for example, here. All right. Here, finally, I want to show you how to save your model. So you would go Save As, and you would be able to save your model. Just give a name, and the file type will be a CPS. And this is pretty much how you create a model, and this is the overview of COPASI. Hope you guys enjoyed the video.